Hi class, and welcome to our lesson on exponential growth and decay. There's an equation for exponential growth and decay, and it's this equation right here, y equals ar raised to the t. So our base in this case is going to be the letter r, because remember the base always has an exponent raised to it, and t is our exponent. So just as a reminder, whenever our base is greater than 1 but less than 0, so in between, whenever it's greater than 0 but less than 1, it is always going to be showing exponential decay. So it's going to be going down and to the right. In a similar way, whenever our base is a number that's greater than 1, such as the number 2, it's going to be showing exponential growth. So let's keep that in mind as we solve these word problems for today. Now our base has to be in between 0 and 1 to show exponential decay, or greater than 1 to show exponential growth. R cannot be exactly 1, and the reason for that is this little problem right here. Notice how every result gets you 3. So this isn't an exponential function, this is linear. And exponential growth and exponential decay problems need to show, obviously, growth or decay, not a constant function. So that's why R cannot be 1. R can also not be negative. Again, we have to show exponential growth or exponential decay. But as you can see with this problem, we bounce back between negative and positive numbers, which means our graph neither shows growth nor decay. It's kind of more chaotic. So that's why our rate, or our base, can never be negative and it can never be 1. Okay, so knowing that, let's talk about our equations. They're the same for exponential growth and decay. You'll see the differences as we do some of these word problems, but the equation does remain the same. A is the initial amount. So whatever we start off with, that goes into that spot for letter A. Rate is the rate of increase, oftentimes written as a percent, and the exponent is time t. Might be in months, might be years, might be seconds, could be any of those. And then y is the amount at time t. So after 5 months, what's the new population? That's going to be our amount at time t, after that many months. Same thing with exponential decay. What we really need to distinguish is if it's growth, if our rate is bigger than 1, and when it's decay, our rate is in between 0 and 1. Let's take a look at our first problem. In 1985, there were 285 cell phone subscribers in the town of Centerville. Not very many. Obviously, cell phones weren't very prevalent in 1985. But the number of subscribers increased by 75% per year after 1985. So how many cell phone subscribers were in Centerville in 1994? So 75% increase from 1985 to 86, and then 75% from 86 to 87, and then 75% from 87 to 88, and so on and so forth. This number is going to get larger and larger and larger. This is going to show exponential growth. We're getting more and more cell phone subscribers as the years go on. So we want to know how many cell phone subscribers were in Centerville in 1994. We want to know the amount at time t. So we want to find y. So y equals A. A is the initial amount of cell phone subscribers, which is 285. Multiplied by the rate raised to the time. So the rate class can be kind of tricky on this one. It's the percent increase, which we see this 75%, and we got to be careful about that. The reason why is because in 1985, there were 285 cell phone subscribers, and then the next year, all 285 of those cell phone subscribers still had one, but then 75% more were added on to that. So it's kind of like 100% of the cell phone subscribers in 85 also had it in 86. And then there was 75% more. So our percent increase is 175%. And we always write this as a decimal, so as far as our rate is concerned, our decimal point is right here. Move it over twice, our percent increase is 1.75. That is what goes into our rate, 1.75. So remember, for exponential growth, you always have to add the percent increase to 100. Because 100% had it from one year to the next, and then it was a 75% increase, so we add that 75. I hope that makes sense. And then again, that 175, to put it as a decimal, is 1.75. Raised to the time t is what happens in this spot. So what is time t? How many years had passed to go from 1985 to 1994? 9 years had passed, so it's raised to the 9th power. So, what is y? We could simply put this into our calculator now. Make sure you follow order of operations. You're going to do exponents first. So why don't you guys take out your calculators and try this. 1.75 raised to the 9th equals, and then multiply it by 285. So make sure you do the exponents before you multiply. So what is y? When you did this by yourself, hopefully you got approximately. Y is approximately equal to 43872. 43,872 people. It grows very quickly. After 9 years, it went from 285 to 43, almost 44,000 people. Very significant. Let's try number 2. The population of a city of 1 million is increasing at a rate of 3% per year. If the population continues to grow at this rate, in how many years will the population have doubled? So what we want to find here is we want to find in how many years. Our variable in this case is going to be time t. So if it started at 1 million, there's our initial amount. That goes in for the letter A. So 1 million multiplied by the rate, and the rate in this case is a 3% increase. It's growing from 1 million and then it's doubling. So this is going to be showing exponential growth. Our rate is going to be bigger than 1. So it's 100% plus 3%. Remember how our percent we always add to 100. And we get 103%. As a decimal, it's 1.03. So 1.03 is our rate. Raised to time t, that's our variable, that's what we want to find. That equals our amount at time t, y. So what do we want to find? We want to find if the population continues to grow at this rate, in how many years will the population have doubled? So in how many years will the population get to 2 million people? That's when the population doubles. So our amount at time t is going to be 2 million. So there we have our equation set up. Now we have to solve for our exponent, the letter t. So in order to do that, let's first divide both sides by 1 million. That'll take care of a lot of headaches, because zeros can be headaches sometimes. Takes care of that. And what is 2 million divided by 1 million? It's 2 divided by 1, which is 2. So 2 equals 1.03 raised to the t. This is why we've done all this work with logarithms and exponential functions so far this chapter, so that we could solve these problems. Because whenever we have to solve for an exponent, we got to take the log of both sides. So now we have the log of 2, that equals the log of 1.03 raised to the t. And then I'm going to do this in this step, class. I'm going to use the power property of logs and say that if it's an exponent, it can come out in front as a coefficient. So t is now multiplied by the log of 1.03. So to get my answer, I'm going to divide both sides by the log of 1.03, and now I have t all by itself. Divide by the log of 1.03. So why don't you guys do that in your calculator? What is the log of 2 divided by the log of 1.03? T is approximately equal to, when you take log 2 divided by 1.03, it's 23.4498 years. 23.4498 years. This is something that is rather significant, because you got to start thinking, boy, in 23 years, if you're like a mayor of this city or something like that, some high up in administrative type of a role, you got to think, boy, if this percent increase continues at 3% per year, in 23 years, which really isn't that long, my city is going to double in size. That means I need more schools, I need more shopping, I need more restaurants, I need more hotels, all that good stuff you got to start thinking about if your population is going to double in size from 1 million to 2 million. So definitely some real life application involved with these questions. Let's try number 3. In the year 2015, Nigeria had an estimated population of 174 million, and the United States had an estimated population of 316 million. Nigeria's population is projected to increase 2.47% each year, while the United States population is projected to increase at 0.9% each year. When will Nigeria's population be more than the population of the United States? So obviously, the United States has a bigger population. We have 316 million. Nigeria has 174 million. However, Nigeria, their population is growing at a faster rate than ours. They're getting bigger faster than we're getting bigger. So eventually, they're going to have more people than us if these population rates stay the exact same. So it's when will Nigeria's population be greater than the United States? That's what we're kind of wondering here. And y equals AR raised to the t. That y is the population at time t. So when will Nigeria's AR raised to the t be greater than the United States' AR raised to the t? So really what we're going to be doing is we're going to be solving an inequality in this one. Alright, what's the initial amount of Nigeria? Their initial amount is 174 million. So that goes in for the letter A for Nigeria. 174 times Nigeria's rate raised to the time t. And Nigeria's rate is 100% plus 2.47%, which is 102.47. If I want to put this into a decimal, move it over 2 times, and there is Nigeria's rate. 1.0247 raised to the time t. I want to find when will Nigeria's population be more than the population of the United States, so I want to find time t. So there's Nigeria's information, and then it's going to be greater than the United States's. So the United States, their initial amount is 316 million, multiplied by the rate, which the rate of the United States is 0.9%. So what's 100% plus 0.9%? 100.9. Moving this as a decimal, it's 1.009. 1.009, once again, raised to the time t. So now we have to solve this inequality. Alright, the first step, a little bit complicated. What we have right here is we have a product on the left side. It's 174 times 1.0247 raised to the t. Same thing here, we have a product right here. So I could use the product property of logs, and I could take the log base 10, so I don't even have to write base 10. I'm going to take the log of 174, and then because this is multiplied, I can expand their logs by adding the log of 1.0247 raised to the t. Okay, so this is a product right here, but I could expand their logs by having the same log base 10, with an addition sign in between. That's the product property of logs. I'm going to do the exact same thing with the United States' side. So it's going to be the log of 316 plus the log of 1.009 raised to the t. Sorry about getting kind of smushed over there. Okay, and now class, what we're going to do here is we're going to bring this t out in front as a coefficient. We're going to use that product property. The t comes out here in front. Sorry, not the product property, the power property. So now that the t is a coefficient, it's now multiplied by. So now class, take out your calculators, and let's just get a bunch of these gross decimals. What is the log of 174? If you do that in your calculator, you get approximately 2.2405. Plus, what is the log of 1.0247? You should get 0.0106 multiplied by t. So 0.0106 t. When will that be greater than the log of 316, which is 2.4999, plus the log of 1.009 is 0.0039 multiplied by t. Alright, you have an ugly equation, but it's not too difficult anymore. It's just a lot of decimals, which is just fine. We're going to solve for t now. Let's get all the t's onto the right side. So subtract 0.0106t. Subtracting... let's do it the other way around. Let's get this to be a positive number. So let's subtract 0.0039t to get it off to the left. Subtract 0.0039t. And then we would end up getting 0.0067t off to the left. And then let's subtract 2.2405 and get that onto the right side. Subtract 2.2405. So then we end up getting 0.2594. Okay, last step. Divide both sides by 0.0067. Divide by 0.0067. So what does t equal, or t is greater than approximately 38.7164 years. So very significant. In the year 2015, we have more people than Nigeria, but if our populations continue to increase at the exact same rate, with ours being 0.9 and Nigeria's being 2.47, I think it was. Yeah, 2.47. In only 38 years, Nigeria's population will be bigger than ours. So that means that if we take 2015 and add our approximately 38 years, sometime in the year 2053, Nigeria's population will be bigger. And that's weird to think about because that's sometime in your lifetime. So very interesting questions that deal with exponential growth and exponential decay. Let me know if you have any questions on that when you get to class tomorrow.